Hello there and welcome to Happy on Numbers where we learn maths the easy way. Now these are questions requested by someone on integration, right? So we'll be looking at it, and I do believe before you approach this question you have a basic understanding on integration. So without much ado, let's quickly go into the question. So we have the integral of 3x minus the square root of x plus 1 over x all squared dx with our limits from 0 to 1. All right. So how do we approach this question? You can approach this with the idea of the integration of sums and difference. So that it now becomes the integral of 3x dx minus the integral of square root of x dx, then plus the integral of what? 1 over x squared dx, taking into consideration your limits. Your upper limit being 1 and then your lower limit being 0. So for this here, we want to integrate 3x, right? So integrating 3x, all we do is we increase the power by 1. So already we know we have 1 here, so we increase it by 1, then divide by the new power, which is 2, right? So what we have here now, integrating it becomes 3x squared over 2 with our limits from what? 0 to 1, minus the second one here is actually x to the power half. So we still increase by 1. So plus 1, this gives us a 3 over 2. Then we divide also by the 3 over 2. If you are dividing now, we have x raised to the power 3 over 2 divided by 3 over 2. And we know when we are dividing by fractions, we tend to do what? Multiply and then reciprocate this over here. You see, so we have minus 2x to the power 3 over 2 all over 3. That is the integral of this one. So we have 2 over 3 x raised to the power 3 over 2 with our limits there as well. Then for this very last one, 1 over x squared, applying the laws of indices, you can rewrite 1 over x squared as x raised to the power negative 2. You see, so integrating it, we have to increase it by 1, which then gives us negative 1. So all over negative 1. We have x raised to the power negative 1 all over negative 1. This negative affects here. So we have negative x raised to the power negative 1. The laws of indices also allows us to rewrite this as negative 1 over x, you see. So integrating this last one over here, we have plus negative 1 over x with our limits from what? 0 to 1. So now that we are done with the integral aspect, we now want to what? Evaluate with the limits. So for the first one, if we put 1, we have 3, then into our bracket, we have 1 squared. You see, that 1 is for the x. So 1 squared all over 2. Then minus, if we put 0 over here, this whole numerator is going to be 0. You see, it's going to be 0. So we have minus 0. This is just for the first one. Then minus for this as well, if you put 1 here, 1 raised to the power 3 over 2. So we have into bracket 2 over 3. Then you have x, which in this case is our 1. And then raised to the power 3 over 2. Once again, if we put 0 there, we'll get 0. 0 raised to the power anything is still 0. So minus 0. Then this very last one, plus, so let's bring this minus out so that it becomes minus, you have 1 over 1 minus 1 over 0. Now this is where the whole problem starts. For this very third one, we know 1 over 0 doesn't exist. You see, 1 over 0 doesn't exist. So what this tells us is if we evaluate this integral, it doesn't converge. It does not converge. So this here makes everything null. If not, all this here would have given us, so this gives us 3 over 2. So 3 over 2 minus 0 is still the same thing. Then minus, this also gives us 2 over 3. You see? But then minus this one that doesn't converge. You see? Doesn't converge. So since it doesn't converge, let's see what to give us. This here gives us negative 1. So we have minus 1. Then this here gives us infinity. So plus infinity. Alright? Plus infinity. So with the presence of, we know if we add all of this, no matter what it gives us, the infinity will still conquer. Right? So this simply means the integral we have over here, this, which is our question, it simply means that its integral is what? It goes to infinity. So it is infinity. And we say it does not converge. So with the same idea, let's quickly look at this. This one is very straightforward. So our solution, we have the integral of so this is how the second question looks like, right? Okay, so for this over here, we would have to apply the substitution. You see, we would have to apply substitution. So we say that let any variable at all, most at times we use u. So let u be equal to 5 plus x squared. If you get u, you would have to differentiate u. So du with respect to x is going to give us, this gives us a constant, so 0. Then 2x, that is if we differentiate u with respect to x. We now want to make the x the subject, right? So du the subject rather, so du is going to give us the x 2x, or let's say 2x the x. All right, now if we look at what we did carefully, and if we have to substitute the u we used over here, it simply means our integral now becomes the integral of x with the cube root of u dx. And if you want to rearrange this one, then we are going to get the integral of the cube root of u, then x dx. You see, this is the x dx over here. I hope you see that. So from here, if you want to make that x dx the subject, let me copy this from here. So if you want to make the x dx the subject, it simply means x dx is going to be equal to 1 over 2 du, right? 1 over 2 du. So we substitute that into what we have over here. You see, we are substituting it into what we have over here. so that instead of integral of 3, the cube root of u x dx, we rather put what? 1 over 2 dx. You see, and since the half is a constant, we can bring it out here. So that we have 1 over 2, the integral of the cube root of u dx. So this is how the question has been simplified, right? And then we now want to apply our integration. So this here, it can be written as, let me get a new page. So it can be written as x raised to the power 1, not x, but then u. So u raised to the power 1 over 3. You know, if you want to integrate, this, we'll increase by 1, so plus 1, then all over our new power we have over here. So 1 over 3 plus 1, which gives us a 4 over 3. And looking at the previous one we did, if you want to evaluate this, we are going to get 3 over 4 u, the cube root of, and this time not the cube root, because you have u raised to the power 4 over 3. So this is what is going to be our integration after this. We have 1 over 2 times 3 over 4, then u raised to the power 4 over 3. All right. So with what we have now, if we have to simplify, we are going to get 1 times 3, which is 3. So 3 over 8. U raised to the power 4 over 3. But let's remember that u wasn't given us in the question. We introduced our own u. Hence, you are supposed to what? Bring back whatever you used as u. So he said, let u be 5 plus x raised to the power 2. You see? So if you want to evaluate, we have 3 over 8. Then instead of the u, we said 5, or let me write it as x raised to the power 2 plus 5, all raised to the power 4 over 3. This here. So this becomes our answer for the integration. But since we have no limit, we would write plus c, because we have no limit. There would actually be a constant somewhere, so we introduce the plus c. All right. Okay. So that is that. Let's go to our last question. So looking at this one here like this, let's quickly go into our solution. We can't apply substitution here because it's too complex, and substitution wouldn't be enough. So I think let's use integration by parts. So we have the integral of 4x squared ln x dx. And for integration by parts, the formula says, I think, integral of u div is equal to u v minus the integral of v, then du. Yeah, du. You see, so you will have to identify which one you want to use as your u, and then which one do you want to use as your v. Right? But then looking at what we have here, integrating ln x is very simple. That is just 1 over x. So let's let our u be what? Ln x. If our u is ln x, then it implies that our div would be 4x squared dx. Right? Now our formula says the integral of what we have gotten now will be what? uv. But we have u, we don't have v, we have div. So it simply means we will have to integrate div, which is the integral of what? 4x squared dx. Integrating this will give us our v. So v is now equal to, if we want to integrate this, we'll increase this by 1. so that it becomes a denominator. So we have 4 over 3 x raised to the power 3. This is the integral. So still applying our law here, which I would like to copy. So we have the integral of our function, which is 4x squared ln x dx becomes u first. And we said our u is what? Ln x. So substituting, we have our ln x, then dot, that is times our u. And we've solved our v, and we've solved our v here to be 4 over 3x squared. Then now minus the integral of v. So the integral of this. So the integral of 4 over 3 x to the power 3 du. And I think we didn't even solve for du. So let me quickly solve for du. We know our u. We know, let me write that here. So we know our u was ln x. So du is just 1 over x. So this was the reason why we made our u the ln x. So du would be 1 over x. So substituting here, we are going to get, we actually differentiated with respect to x. So du dx will be what we have over here. Du dx being what we have over here, if we take note, we have du over here. So making du the subject from here, we have du being equal to 1 over x dx. So this is what we want to substitute over here, right? So 1 over x dx. Now the laws of indices would teach us that this x should cancel one of this x. So it simply means the integral we want of 4x squared ln x dx, which is equal to ln x times 4 over 3x squared minus the integral. We are going to get 4 over 3x squared dx, right? X squared dx. So this is now what we want to integrate. So the ln, let me rewrite it this way as 4 over 3x squared ln x minus the integral of this. The 4 over 3 is a constant, right? So times x, its power increases by 1, it becomes 3, then all over 3, right? So evaluating this, we have 4 over 3 x squared ln x, then minus 4x cubed all over what? All over 3 times 3, which is 9. You see? So this becomes our integral here. Then we add plus c because we have no, what do you call it, limit. So what all this means is what we have integrated, which is the integral of 4x squared ln x dx, is actually equal to what we have over here. That is 4 over 3 x squared ln x minus 4 x cubed all over 9, then plus c, as simple as that. So I do hope this video will be helpful. If there's any clarity you need, you can always let me know at the comment section and I'll get back to you. Happy learning and stay blessed.